Hello students, in number theory, today we discuss average of arithmetical function. Before going to discuss average of arithmetical function, let us understand that there are various identities which are satisfied by arithmetical function such as tau of n or d of n, number of divisors of n, and sigma of n, that is sum of the divisors of n, and Mobius function mu of n, and Euler-Toten function phi of n, Mangold function big delta of n, lambda of n Laplace function, and sum of n with suffix alpha, alpha powers of divisors of n. In this lesson, we examine the behavior of these functions or other arithmetical functions f of n for large values of n. Why we introduce the average of arithmetical function? We understand the mean of arithmetical function for some natural numbers n. Take this example, that is d of n, sum of the d of n, where n is equal to 1 to 5. That means divisors of 1, divisors of 2, divisors of 3, divisors of 4, divisors of 5. So we need to calculate the mean of divisors, number of divisors of all these functions whose sum by 5 is 2 here. That means d of 1 is 1. Why? Because number of divisors for 1 is 1. Similarly, number of divisors divides 2 is 2, 1 and 2. Similarly, d of 3 is equal to 3, d of 4 is also 3, and d of 5 is equal to 2, and whose mean is by 5 is equal to 2. Similarly, we calculate the sum of divisors of n for n is equal to 1 to 10, and its mean is 1 by 10. So whose value is 27 by 10 and is equal to 2.7. In this manner, if you try to calculate for large values of n, we use this formula. Is it easy to calculate the mean of n for large values of n? Obviously, it is difficult. In this situation, yes, it is very difficult to determine the behavior of the mean of arithmetical function for large values of n. We introduce the concept of average of arithmetical function. So let us take the definition. For any arithmetical function f, we define the average of the arithmetical function to be the real function f from r plus to r, defined by capital F of x is equal to 1 by x of the sum of f of n, where n is less than or equal to x. Here n is the natural number less than to x, and n is equal to 1, 2 up to integral part of x. Suppose if x is the natural number, integral part of x is nothing but the natural number itself, n. Therefore, f of capital N is equal to 1 by capital N, sum of f of small n, where n is equal to 1 to capital N. Or the other form is sum of f of k, where k is equal to 1 to n, whose mean is 1 by n, is equal to tilde of f of n. Here it is understood that the index k varies from 1 to 2 integral part of x. The greatest integer less than to x, if 0 if x is lying between 0 and 1, then sum of f of k where k is less than or equal to x is empty, and so that we assign its value as 0. And for further discussion we need the Euler constant, C Euler constant, where C is equal to limit of the sum 1 plus 1 by 2 plus 1 by 3 plus dash s plus 1 by n minus log n, where when n tends to infinity.